Hello, my dear students. It will be lecture number 16. It's the final one in the line of lectures in this discipline. Next, we have records only about practical tasks. And do pay attention, please. Inventor, you see the list? List divided onto 6 groups according to what our university did with all amount of students of your specialty. You see your names, your family names, your names in this list. And in each practical task that you have, please do not forget to refer to this list. No, it's each time the same. In front of your family name, you have number of variant. Find yourself where you are in a group and number of variant you see in this list. And next, follow to video classes explanation, follow to this short explanation here. Mostly will be repeating of the tasks variants, like for the first and second task. You see, it's just list of the same files that you have in talk. And as to the third task, again, initial data for your design, slides. Here is a file with slides, and in general, some steps, step by step, what you're supposed to do. And what do you see as this pinkish color page with pen? It's some receiver of your tasks that you should download it into. Well, let's continue. And we have jumped over, literally jumped, by some processes which we have arranged according to the recommendations of our textbook. We have arranged them into 5 boxes, and some of them I have mentioned but not even tried to explain you. In particular, I said that I do not talk to you about techniques of transformation of surfacial properties and what is hidden inside. Above all, it comes about heat treatment, like hardening, baking, annealing. In English, you meet it with either annealing or baking name. Some another methods of heat chemical treatment like carbonizing, anodizing, so on, and making of protective coatings. Whatever sort of these coatings, whatever way of applying the coatings is, because if we try to even just survey this column, this box, it will be a couple of more lectures supposed to be. What should I remind you else? No, next we will talk about the last one. I said you since beginning that practically all such groups you are studying, those who study technology as specialization, they study the whole semester, they spend the whole semester for big groups which are mostly for groups which are selected with lilac color. Mostly like this, but really some of them in different disciplines. Like casting and primary deformation and forging, it's one discipline. Sheet metal stamping, it comes about deformation and shear cutting, it's another discipline. Conventional and non-conventional machining, on one hand, one discipline about cutting, and some elements of the same processes, they are explained in another discipline about welding. Welding, which is responsible for making joints in transformational spatial positions and some protective coating and some ways of cutting, it's also another discipline. About additive manufacturing, we have some general ideas, let's say, to give you about in welding. Usually one of lectures, maybe, or half of lectures, it's to give you some ideas about these techniques. But we have separate disciplines about additive manufacturing. So all these stories we're telling to each other, they are just solving of all the variety, some general, not all the variety solving, but some generals solving in possible ways of process raw materials into semi-products and semi-products into final parts. But it was only about manufacturing of individual pieces without any assembly operations yet. But we understand that any technical system, any device, actually it consists from these pieces, and it's necessary to arrange them correctly inside and to join them in order they work as a whole, in order they fulfill their functions properly. And on the way to the customer, this assembled item also need to pass some tests. Well, now, before we go finally to talk about assembling, I will remind you some elementary things that maybe I already mentioned, maybe not clearly mentioned. Let's talk. Slides. What do you see right now? It's called sequence of aircraft manufacturing. No, it's not only for aircraft valid actually. If we change some flight tests, for instance, just for tests, for ground tests, it will be practically the same for any industrial object of manufacturing. First, we manufacture the parts. Next, we assemble them. Maybe we have some mounting work to do. All this is accompanied with technical inspection that is not mentioned here, and ground and flight test for aircraft or at all testing program for any another device. Actually, it's final before it will leave enterprise on the way to the customer. Well, what we been talking about already? Do pay attention. Only about this. That's it. How much we spent for manufacturing? We spent all for seems like 1/6 of this line. No, that is not quite true. Let's imagine that this sequence, it's all this sequence is 400, do forgive me, 100% of our work. It's called total labor input for aircraft manufacturing. One aircraft to be produced, we spend all our work, we spend all our time. It's labor input equal to 1 or equal to 100%. Manufacturing of parts in this total labor input of aircraft manufacturing is around 25-30%. Sound weird. Each airplane consists of from millions to hundreds of millions of individual elements. And all these hundreds, it's only 30% of our work, 1/3. What we do all another time. Around 5% of labor input goes on the ground and flight tests. Also, it may be said that around 5 additional percent it's for permanent inspection, because inspection, what is the test difference with test and with inspection? Intuitively, maybe understand that inspection, it's like regular checking on the way. Let's say we are checking parameters of technological processes, of the object itself, of surroundings parameters. This inspection is necessary to make sure that we follow to all the norms of our technological processes, safety rules, and so on, that we are on the right way. Let's say before we meet problem on the ground of flight test, when everything have been done already, and at finally you will see that something was wrong at the beginning of this chain. It will be it's too much. It's too much expensive, because one airplane, of a passenger airplane, for instance, it costs around from 5 to 15 million dollars. $1 billion in English. And in case it's some sophisticated fighter or bomber of new generation, it comes already about hundreds of $1 billion. Finally, we can't afford such spends for nothing. So we permanently, since incoming the raw materials to enterprise and each next sub-steps, we have technical inspection of different kinds. Geometry, mass, chemical compound, a lot of them. And assembling. Do pay attention. All the center of the scheme, it's about assembling. I also outlined the mounting work. Next, I will talk about, and you understand that assembling and mounting work, they are similar by their inner life, let's say, by their inner context. But assembling, we call locating process. Assembling is a process of locating, temporary clamping, and final joining of assembly components of elements or structure or some product or whatsoever. And mounting attentively is a process of locating, temporary clamping, and joining of assembly components at the place of their fuse operating. So difference is that assembling we understand as assembling is creating the whole device, whole vehicle from pieces. And mounting usually is understood as aiding by the means of assembling, also by this locating, clamping, and fastening finally. But like by aiding to another existing vehicle, or by aiding to the place of their fuse operating somewhere stationary, for instance. No, intuitively it's clear. Look, like assembling of the engine of automobile, and you may imagine some factory where it happens. For instance, someone assembles the engine, and mounting of the engine to automobile, it's also assembling, because you need to find its proper way, locate it, clamp it temporarily, and join it to automobile. But by essence, it's the same assembling, but it has this aspect that it's like added to another vehicle. What we understand as mounting while manufacturing of the airplane, we have some incoming components, and these incoming components, they may go from another enterprises. Now we see structure only. Let me to find another slide. Practical is the same, sorry. And these another components may go from different places to you. For instance, you have airframe, and your enterprise producing airframe and will accomplish the final assembling of the airplane. But engines, maybe landing gear, passenger seats, elements of radio navigation equipment, do forgive me, equipment of toilets for passenger. It's not produced at the same enterprise typically. It comes from somewhere else, from another enterprises with their specialization, or even from another companies from another countries. Well, let's come back to the story about assembling and about the manufacturing of a aircraft as a whole. I'm already said you that all the classifications we're talking about, they are conditional, only to arrange our knowledge, our ideas in the brain. And when it comes about aircraft manufacturing, usually people show another classification. But in this another classification, they are talking about the same processes. Let me please to work quickly. Do pay attention next. What if I talk about airplane manufacturing? Let it be airplane, in order not to spend time manufacturing. And usually it's divided onto. It's so-called blank production, it's called. It comes about parts production, actually. Blank manufacturing. No, at least it's translated like this in our countries in order to translate, just direct translation of our terminology. Okay, let's say that it comes about parts and workpieces production. Parts and workpieces productions. because some things may be production, manufacturing. Some things they are produced like semi products, and next they goes to next shops. Manufacturing. Next, it comes about assembly, manufacturing, assembly and mounting work. Assembly and mounting work. And finally, it comes about testing. We didn't talk yet widely about so-called certification testing, but I hope you remember what I mentioned, that do not confuse, do not mix up certification tests of the new airplane type and flight and ground tests for each particular airplane that leave the enterprise, that go out enterprise gates. Testing, actually, it goes out not via the gate, but from airfield normally. But some aggregate enterprises, which produce only aggregates, not the whole airplane, of course, they send pieces of the airplanes they have been produced by means of another airplane, so by train or by whatsoever, maybe by automobiles, but they send it via the gates. Well, parts manufacturing group, assembly and mounting work and testing. I'm already said you, here is around 30% of labor input. No, labor input is not the same that time, but approximately the same. Assembly and mounting work, it's around 65-70%. And the testing. No, let's see that all the possible variants of testing, 5%. You understand that it should be here ranges, not like I write the quite exact values, ranges, and of course altogether these ranges, they are not equal to 100 because there are variants. Somewhere it will be 25, 65, and 10. Some way it will be another distribution of values, depending on the complexity of the airplane and depending on its size, purpose, and so on. Well, parts manufacturing. And here we have shops. Why it's divided like this? Because usually it's divided, literally now this technical system for aircraft manufacturing, it's divided on another principle, not by kind of manufacturing, mostly parts manufacturing, it's division by shops based really by kinds of manufacturing, mostly, as I said. When it comes about assembly and testing, it's already another principles of dividing of the shops. It's so-called aggregate principle. And do pay attention that here we have shops. No, the primary one, casting, but I'm already said you that casting not much using in manufacturing of parts themselves, if only it comes about interior, for instance, or something like this, and it comes about plastic, about polymer casting. Mostly casting used in aircraft manufacturing for making the tooling, not for making the parts of airplane, because it's considered the normal kinds of casting. No, normal, I mean conventional, typical one. They are not reliable. Part strength is not reliable. Part fatigue life is not reliable. Next, besides of casting, we have forging. Forging is a great thing because we need forging for some elements which are massive, for some elements which need, no, let's say, of crucial reliability. We need compulsory forging semi-products. Next, we process it by machining. By some places, not everything, not all the surfaces. Besides of forging, of course, we have sheet metal working shops, sheet metal. And this sheet metal, usually these shops, they are also divided by work pieces, like sheet shops separately, and profile and pipe shop also separately, because it's convenient. Equipment will be different for them. It's convenient to have different shops for organizing the work with different equipment. The same by the word about, for instance, subdividing this casting forging shop. Why? if casting rather similar to the forging, the difference is that casting in liquid state and closed die forging in solid state. Equipment is different. Machinery quite different that necessary for accomplishing that or another processes. And as equipment is different, dividing into shops like this: casting processes and forging processes. Forging, open die forging and closed die forging, consider it like similar processes because they use the same equipment. However different they are in their physical principles in what happened inside, let's say, nevertheless, they are in the same shops usually because they use the same equipment. Sheet metal stamping, I'm already said, and in the same shop you will meet cutting equipment and deforming equipment because it's convenient to have it all together. They are not divided like to groups like here, for instance, in this classification. Next, we have shops compulsory of machining and machinery shops. They at all we might have some of them again depending on machines you're going to use inside, and not by that is turning shop, that is milling shop, that is brochery shop, for instance. No, not like this. Here is again it comes about the deviation from principle, let's say, like short-sized parts, little parts, comparatively little parts of complex shape, for instance. Long-sized parts, but of more primitive shape. It comes about different stringers, caps for spars, and so on. And medium-sized parts, and it will be 3 different shops, maybe even more than 3 different shops will be. Next, what about assembly shops? Let's take another color, for instance. It's already practically not visible anything in my scheme. Shop for assembling. No, look, I'm already said you another principle. I still didn't explain what does it mean aggregate, but principle of aggregate division says we need for different aggregates different shops for our own convenience. So we have wing shop, wing assembly shop, fuselage assembly shop. The truth is that usually fuselage assembly shop, it's not the only. We have, for instance, nose fuselage shop, central fuselage shop, and aft fuselage shop. Some of those shops, maybe. For wing, usually it's enough to have one shop. And we have, no, it's maybe called tail unit or empennage shop, shop of high lift devices or flight controls. For instance, let it be empennage shop here. Let it be additional shop of flight controls. In case we have composite materials in our airplane, we additionally need one more separate shop, flight controls. Because when it comes about mechanical fastening, when we're working with metal and metal fasteners or welding, let it be, it's one group of processes. If you have composites, it's already another group of processes. And all these variety composite materials. Practically, no, in our standards, composite material made parts, they are considered like parts in our standard. But what is happening inside of composite material shop, it's really assembly operation. They have special tools for forming the layers of composite, and they have very special equipment for it. And actually it looks like assembling when they locate layers of composite with respect to each other, and next finally fastening. But fastening, it's let's say of adhesive type, maybe, because binder, which is between layers or inside of these layers, binder change polymerize due to additional temperature and additional pressure in special devices, which either oven or even autoclaves, so call it, with additional pressure, pressurized oven. And practically it's more similar to assembly operations. And so like they by standard they are parts, but in real manufacturing it's considered like assembly operation. And finally all this variety finish it with final assembly shop. Final assembly shop, it's like finishing everything. And this final assembly shop is already meet not only what you made in your enterprise, but also meet the components came abroad, let's say from another enterprises, incoming components. No, and finally testing will be in special, it's called airfield shop. It's called airfield shop, like this. And this airfield shop, it's usually divided into two stations: ground test station and flight test station. Airfield shop. So what I missed, what is typically for me, I missed here in parts manufacturing, I forgot about shops of heat treatment and about shops of coating. But heat treatment, coating, so on, it's maybe one shop, maybe two different shops. No, for painting, for mechanical coatings, usually they have separate shop. For so-called heat chemical treatment, no, like carbonizing, anodizing, so on, it's in the same shop. Sorry. Well, I forgot to record the time, people. Do forgive me. If it will be too short or too long, do forgive me. No, right now I see, and let's imagine we started. Let's imagine we started at 2 o'clock, okay? Let's refer by 2 o'clock and we finish approximately by 15 with minutes. I need to write it each time in the paper and hold it in front of my nose. Do forgive me. Next. Where I stopped it. Yes. Aircraft manufacturing shops. That is, in general, dreadful sketch, ugly as usual. The sketch of shops of aircraft manufacturing that necessary to produce one airplane. Is it enough? No, but what is a no, we will see later. Right now, we see not all the enterprise, but we see only shops of so-called main manufacturing. Main manufacturing is involved in manufacturing of objects that we are going to sell. But we also have so-called auxiliary manufacturing and servicing manufacturing shops. What are auxiliary manufacturing shops? We will see. What are servicing manufacturing shop? I may say it at once, and certainly you understand it. I already mentioned it dozens of times. In order to work with that or another technological processes, you need electrical energy, you need somewhere you need water, you need somewhere pressurized air, compressed air, and so on. At least you need some light in your shops. Someone, but not the employee of main manufacturing who is responsible. They are responsible for their process, they accomplish in their machine or at their working station. But they should work in conditions that someone has prepared to them. Light, water, air, compressed air, electrical energy, whatever, someone must provide it. And servicing shop, usually they are shop which provide functioning of auxiliary manufacturing and main manufacturing. It means that they are responsible for energy supply, for water supply, for repairing of shops, and so on and so forth. There are shops and services in each enterprise who are responsible for normal functioning of another shops. They are so-called service manufacturing shops. They are not reflected in the scheme. And before, for instance, casting or forging or assembling start work, we have already seen, and we will see, at least sovereignly, that someone need to design, to produce a lot of tools and tooling for them. Some of tools it's maybe bought. No, let it be all these machinery tools like mills, turn cutters, inserts, all this variety may be just bought somewhere in shop, in internet, company, dozens of company who produce it, and uh, one is like boasting in front of another that I am the best and do buy my product. A lot of such companies. But there are specific tools and specific tooling which no one may produce besides of you. Or at least maybe some very individual companies who specialize in the work of designing of such a tooling. No, in Western unions, I have seen, no, in internet, I have seen, of course, not in real. I have seen time to time companies which able to produce tools and tooling for aircraft manufacturing. And the interesting moment that they usually work with aircraft manufacturing and with automotive manufacturing. And to be frank, these two industries in technological processes, they are rather similar. We have a lot of similar processes to use. No, starting with sheet metal stamping, for instance. Well, let's come back to from this picture to what we have seen already. Once again, manufacturing of parts, assembling and mounting, ground and flight test. But why it's written here? Unit assembling, aggregate assembling, and final assembling. Now, about final assembling, I hope you understand. What if, let's imagine that we, instead of divide assembling onto some stages, we'll try to assemble the whole airplane as a whole, not since beginning, the whole airplane. We have millions of parts. We have what really millions of parts. In order you may imagine, I have example in one of files that I will send you after the class, Nisa. Here is. What does it mean? A lot of parts. Look at this. In order, it's more easy to you to listen. Around 50,000 of parts. It's only the wing, and that is information that I heard in different movies that company made provide about the airplanes. Learjet airplane. It's little airplane. It's business jet. It's flying cab actually, and this flying cab for billionaires, luxury flying cab. Only the wing is around 50,000 of parts. It's without fasteners. 50,000 of parts in left wing, half of wing, left and right wing, and center wing. A380. Imagine, yes, A380. They said in a movie that they have 500,000 of parts in the wing. This flying cab, 50,000, Learjet wing, 50,000, Airbus wing of their greatest airplane, 500 million of thousands of parts in one wing without fasteners. And do imagine that all this without fasteners we bring to the whole, to the only working place and trying to work. It's impossible. Narrow place, it's called narrow field of operation. Narrow place, you can't work, you can't involve hundreds of people to work simultaneously. They have no place to work. Do use your imagination, you understand it very clearly, I hope. That is why usually airplane is produced by pieces. What, like we see it approximately, like we see it here. All the work is divided into pieces. These pieces produced by different shops in parallel. That is resulted in more convenient work. That is result parallel work. It means that labor input will be the same or even greater bit. Labor input seems like the same. We spend the same efforts to produce it, but time is significantly reduced because all the work goes by parallel way. Until someone produced central fuselage, someone produced aft fuselage, someone produced wing, and someone is involved in producing of flight controls. And by some deadline, all these aggregates should meet, and next it start final assembly. But moreover, it's a period that for big airplanes, it's convenient even to have some preliminary stage of assembling. And this preliminary stage of assembling is called assembling of units. So not even the aggregate as a whole is assembled at once, but first we assemble some portions of particular aggregates. Next, they join intersections and aggregates. And finally, all these meet in final assembly shop. And additionally, it meets there with engines, with landing gears, with different types of devices and different types of equipment for whether it's a military airplane or passenger airplane. I hope you get an idea. Let's come back to scheme. So first, unit assembling, next, aggregate assembling, and final assembling. Aggregate assembling, it means that there people fulfill assembling also of so-called compartments and sections and aggregates. Unit assembling usually comes only about units. Do we have separate shops for them? For this units assembling, for this aggregate assembling? No. Unit assembling typically, besides of the greatest corporations like Boeing, for instance, unit assembling typically is accomplished in the same shop what aggregate assembling. For instance, units of the wing will be in wing assembly shop, units of the central fuselage, like frames, will be in the central fuselage assembly shops. Let's come back to slides to see what we understand in those aggregates, sections, and so on. No, that scheme is already well known for you, and however weird, it corresponds also to the technological idea of the aggregate. Aggregate is understood as the largest assembly component of the airplane, which has its own function. No, it should be said that it's finished or completed in design and technological meaning. Completed in technological meaning, it means that it may be assembled finally at the separate working place, and next it just join it to another components without changing inside, let's say, or approximately like this. And when it comes about the structural completeness, it comes that it's theoretically at least it's maybe unjoined, for instance during maintenance, unjoined and upchanged to the identical one in order to repair, for instance. Well, aggregate is the largest assembly component that able to fulfill its own function. Will not stop on this right now. I hope in general you understand. Wing function to create lift to accommodate the fuselage to accommodate and so on. For each of these aggregates, it has a separate function that it's able to provide individually. No, not quite like this, you may say them about flaps, for instance, or elevator that may provide individually without another aggregates. They may provide control of the whole airplane. Not like this, of course. No, they are called conditionally little aggregates. In general, aggregates are wing, fuselage, stabilizer, fin, landing gear, engine, not even engine nacelle, but engine, no, and so on. Well, but as I'm already said you, it's not convenient big multi-part components, aggregates, to assemble at the one working place in case you have big program of manufacturing. In case you need to produce the only airplane, no one will bother with organizing of separate working places, divided into little pieces. More probably it will be 5 stations like wing, fuselage, so on, literally. No one needed to spend additional money, time for preparing of manufacturing with various tooling at all. So when it comes about serial manufacturing, no, in terms that program will be counted in tens and hundreds. In this case, of course, it will be long preparation and it will be differentiation of assembly work compulsory to the aggregate compartment section, so on. In case you need to produce the only airplane or couple of airplanes, like an experimental planes, for instance, more probably it will be 5, 7 assembly stations for different aggregates and next final assembly. Compartment is the portion, and you see this portion of the aggregate, finished in design, in structural and technological meaning, so on, obtained by division of normal plane, normal to longitudinal axis. Compartment of the wing, for instance, is center wing or left wing, right wing, or half wing, of course, you understand. And one more name is section. Section compartment always has a closet contour. What that is according to our standards. That is compartment, that is section. You see, fuselage compartment, fuselage section. Also, a very big portion of structure finished in design technological meaning, but it's has no closed aerodynamical contour, and it's maybe obtained by splitting by any planes, perpendicular, parallel, even deviated with declined with some angle to the axis. What should I say? In English literature, in English English talking Western countries, I practically have not seen such division, such clean division. Like this is compartment, this is section. They are not bothered much about uh, terminology, as maybe you have already noted from my words, and that is why they use mostly they use word section in that meaning that we use compartment and section. And next one is a unit. Unit is, you see, whatever that consists of two and more parts, may be called unit. Distinguishing feature that unit is not able to fulfill any function separately from another units. Only in company with another units, it's able to fulfill some functions. Examples of units: spars, frames, ribs, whatever you may imagine. In the structure of the airplane, mostly these little things, they are units. And one more, they are not little in sizes, maybe, but they rather little in nomenclature of parts. When it comes about nomenclature, it's from 2, as I'm already said, 2 parts minimum. No? From 2 to 15 parts, let it be, in nomenclature. When it comes about amount of parts, it's maybe even some hundreds of parts. But they are like repeatable in nomenclature. Some, let it be 15 stiffeners, for instance, in the spar, but as they are the same, in nomenclature, they goes like the only part. And and fasteners, various fasteners. Mostly we're using the rivets, of course, in metal airplanes. But if I recollect the whole variety of possible design of airplane, where we use metal, wood, fabric, plastic foam even used for filling some inner cavities of the light airplane. Composite materials in the view of honeycomb, composite materials, so-called sandwich panels, or composite materials made of fiberglass or of carbon glass. No, unbearable variety, and it's not possible to say. We are mostly use rivets for metal airplanes, for modern structures like of middle class, let's say passenger airplane, cargo airplane, military airplane, business jet. Mostly they use riveted joints with including of screws and bolts. Not much. Bolts only in heavy loaded places usually. Mostly about rivets. Some materials they are used. We use welding, for instance. No, welding is also a rather specific process, and not elements of the airplane may be joined by welding because of peculiarity of the process and reducing the strength and so on. But resistant welding was successfully used in airplane structures instead of rivets. And it was already a good tradition of Antonov Design Bureau. They used resistance welding instead of rivets. Strength was the same, but weight was reduced significantly. Well, one more type of unit, I should say, and this one more type of unit is a panel. Typically for fuselage or for maybe also you may meet it in a wing, in stabilizer, in fin. What we understood as panel. Right now you see people assemble or technically inspect the panel. Panel is the patch of the skin, like the piece of outer skin, which assembled preliminary with supportive elements, longitudinal both and transversal. For instance, with stringers, as you might see, with this semi-monocoque fuselage, typically panels are assembled separately, and next they will meet, like we have seen in the picture, what you see. Panels may be assembled separately, and at the aggregate assembling of the central compartment of the fuselage, they will meet all together. Panel is the piece of skin, patch of skin that's supported with longitudinal and transversal elements, not compulsory the whole frame. If it's so-called normal, regular frame, which consists of the only rim practically, some profile, which is the regular frame, then it's usually joined to the skin at the stage of panel assembling. If it's something more complicated, like reinforced frame, or it's some bulkhead, for instance, they are assembled separately, like separate units, and panel in this place, it has like skipped place. No frame there, but next later it will be joined to that frame that is called reinforced or bulkhead. So panel is already like reinforced piece of skin. What is necessary for? What it may give us? No, do forgive me. I will not search this picture right now in another slides. You do remember maybe already I said it sometimes that wherever possible we need to remove the human, a man, a woman, whoever, human, remove human from the chain of making decisions, if possible, from the chain of from technological chains. Why? Because any human is the source of mistakes. Occasional mistakes when equipment may do systematic mistakes, and it's easier, rather easier, to identify these mistakes and to find the reason and remove this reason or somehow compensate this reason. Human are unpredictable. Humans, it's something, by yourself. And why not on purpose? So happen. Better to improve quality wherever possible, to remove human from technological chain, to minimize effect of human actions to technological chain. What, for example, I said that mostly we are using rivets for producing the joints, for joining the elements. There are variants, and these variants are manual riveting, automated riveting on presses, for instance, and robotic riveting. What does it mean to remove human from this technological chain? Preferable will be automatic or even robotic riveting, in case you have money for robots. No, let it be at least automated one by using the presses. Press will give you uniform force each time. Press may do more than one rivet for one stroke, so-called group riveting, so on. And moreover, press give better quality in terms of fatigue life, of the future fatigue life of this place, of this rivet, because of better tightening of the rivet in the hole. So automated riveting is preferred. But if you're working already since beginning, you already assemble it like the whole cylinder, how you bring the cylinder to the press, how you will operate with the cylinder, with rivets, which along each stringer, it will be some tens of rivets in one, let it be panel. No? When it comes about the whole fuselage, it comes about thousands of those rivets already, tens of thousands. And these repeatable actions, which will be repeated by press accurately, with stable quality, so on, you can't fulfill in case you close this compartment since beginning and try to assemble it like closed compartment with closed aerodynamical contour. But when you assemble it by pieces, like panels, like this, you have access from both of sides normally, open access, so-called, and you may use automated machines like presses, for instance, instead of human force. On one hand, it's reduce human labor input and save labor forces. On other hand, it's increase quality and so on and so forth. So this differentiation of assembly work to different working station, it has a lot of reasons. And one of these reasons that it's shortening the general time of assembling due to paralleling of the work. Another reason that it's create your conditions for flexibility of the work, for increasing the automation level of the work. And by this, it's increases the quality of the work, more probably. No, and another important reasons might be that you will study when you study assembling, but general idea is differentiation degree is deeper and it's better to deepen this differentiation degree, to increase this separation of airplane structure to pieces while assembling. It's better, but it's balance of this better with the cost of this better. In case you have wide program, better to separate to more pieces your airplane and to produce them separately. In case you have less amount of airplane to produce, whatever, during 1 year or during 10 years, little amount, then it's necessary to calculate what will be more profitable for you. Each time, do remember, we have secret aim. And this secret aim is directed to us, not to providing the happiness of our customers, but to providing of our own happiness by saving the money, labor input, time for manufacturing, and so on. Well, once again, maybe it's a bit jammed. No, forgive me. Unit assembling first. Little elements we assemble, like frames, panel, longeron, diaphragms, ribs, and so on. Next, these units meet each other in the next stage of sections and compartment assembling. If you have considered that it's not necessary to have some preliminary, not preliminary, but intermediate stages of assembling, then instead of them, immediately it will be already aggregate assembling. It means fuselage, wing, stabilizer, landing gear, so on. And all these will be met in the final next shop of final assembling, where practically at the exit of the shop, you will have final airplane. Like this. Oh, I forgot to change the slide. I've been checking slide before class, and you see I spoiled the fact. Like this. That is a shop of final assembling. And this final assembly shop, usually in the line of shops, in the block of shops, it's a really final block in the whole long building, huge actually building. And final shop is opened, the whole wall of final shop, it's the door. Last wall is the sort of gates, sliding gates. And when airplane is finished, these gates are opened and the airplane goes away and replaced to the airfield and airfield shop for testing. Very well. What is the time? Time is screaming already, sorry. And I said that, however interesting now this story about shops and about assembling, it's also necessary to reconsider what we should do before we start manufacturing. Before we start first ever part of this airplane, we need to start to finish preparation of manufacturing. If you remember, I said that our field of technologies of manufacture, it's not only the systematic, continuous, repeatable manufacturing, but before of any manufacturing, we have stage of technological pre-production. In English, it's also called lead time. In our languages, direct translation to give you, we have so-called technical preparation And inside of technical preparation, we have one more stage, which is called technological preparation. Technical preparation is understood as scientific work, design work, and preparation of serial manufacturing of technological processes. Technological processes, technological preparation, technological pre-production is understood only as something that deal with manufacturing. Means that we have already finished design from designers, means that we understand how much things we need to produce, and then we may to plan our manufacturing, to select technological processes, to design the tooling, so on and so forth. But it doesn't mean that we start work only after designers have finished their work. As only designers start their work, technologists, they are already watching designers, what they are doing. Maybe they design something that is not producible. And these not producible or producible parts, typically it's called, no, in our country, I already said you, those properties of parts, they are called technological efficiency. Literally, it comes about properties that reflect technological conveniency. Conveniency of parts for manufacturing. Is it convenient to be produced or not? Or it will be too difficult, too expensive, too long, and unpleasant at all in different ways. No, about unpleasant at all, you understand I'm kidding. Technological efficiency is the property. Technological efficiency of structure is the property of structure, the complex of properties that reflect conveniency of structure for manufacturing in terms of saving their resources, material resources, uh, labor resources, time and money for manufacturing and pre-production. In English language, I'm already said in English talking countries, they have such a noun which is written immediately with dashes. And these nouns, they are design dash for dash manufacturing, DFM with big letters, design for manufacturing, DFA, design for assembling, design for maintenance, or one more word that you may meet, it's called manufacturability, producibility, assemblability. One more word, yes, one more word. It's not one more word, it's the whole group of words like weldability, castability, and so on. It comes about the properties of product or piece of product, like part, that reflect its ability to be produced with that or another way with minimum of costs, whatever cost it comes about: money, time, material, and labor resources. I haven't finished the story about the technological division. What does it mean, technological division? Aggregates, compartments, sections, units, panel as a kind of unit, part is considered the least structural assembly component, the least in division, not least by meaning, by its role, by its meaning, or the least but not last. Elementary assembly component made without assembly operations. It's considered like part. Examples of parts you see right now, you have already seen them dozens of times. Well, and let's come back to these slides. I'm already said you, in order to start, I forgot to mention one more important thing. Assembly manufacturing, what in a book, I open it on purpose. Here is Michael Gruvel book, mechanical assembly. Mostly there it will be about methods of joining, mostly. And previous chapter he has in a book, welding. It's for mechanical engineering as general, like not even for automobiles, but something like uh, no idea what to compare with whatsoever. It's not about aircraft manufacturing. Why? Just because aircraft has too much peculiarities, and in this file next you will refer to it, I hope. These peculiarities are referred. red color, it's the peculiarity of aircraft. It's all no, red, pinkish, something like this. And each of these peculiarity will resulted in the list of problems during manufacturing. But right now we will not talk about this because of lack of time. In practical class, we'll try to talk about assembling details and about the pre-production details. Right now, do remember the no, like some facts about aircraft assembling. Too much parts. Next, these parts, they are mostly of complex shape and demands to their accuracy, demands to their geometry are very high. But together with these high demands to accuracy, they are too thin. Mostly they are shell-like spots. They are thin. We have seen it in structures, in pictures of structures. We've seen it hundreds of times already. Yes, what they looks like. And those very accurate things has a tendency to lose stability, to lose their shapes under own weight. It's called not enough stiffness. And what it resulted in? On one hand, we need high accuracy of manufacturing of these parts and assembly as a whole. No one actually interested, no any customer interested in the accuracy of individual parts. They are interested not even the accuracy of assembled unit as a whole. They are interested only in flight performances of the airplane as a whole. You understand it? And to provide the flight performances as a period, it's necessary to provide the correct geometry of the aircraft. So geometry responsible for flight performances, and geometry, on other hand, it's not able to hold itself at all during manufacturing. After you've been manufacturing the part with very high accuracy, you spend so many efforts, you spend your mental energy, you have invented something to improve the manufacturing, and while transporting to another shop for assembling, the part has lost its own shape. Great. And that is why in manufacturing of aircraft, at one hand, in assembling, we force it to use, they are called assembly jigs. Ho ho ho, oh, something is visible already for you. Special devices for locating temporary clumping of aircraft structural elements, and the most of joints they are also fulfilled immediately in such uh, assembly jigs. Actually, these jigs, no, by classifications of jigs and fixtures, they are mostly fixtures, to be frank. If we follow to their own classification in English, but as they only for locating and clamping, temporarily clamping, they have no devices for directing, for guiding the tools while assembling. Tools will be drilling, drill bits, I mean. Processes of drilling, processes of riveting, they are fulfilled immediately in this heavy rains. It's like falling dogs and cats, like it's called in English, and completely at the empty place. A minute ago it was full sun, and now it's the wall of water out the window. Well, once again, assembly jigs. But in English talking countries, it's called jig. Whatever its fixture by their own classification, they call it assembly jigs. Logic always at the first place, you understand, in their terminology. Great. Assembly jigs may be of different complexity because it's maybe unit assembly jig, rather simple one, and it may be compartment assembly jig, or it's maybe aggregate assembly jig, and they will be quite different. Look how simple looks panel assembly jig, for instance. Practically nothing about. Panel is a patch of skin, you do remember, supported with stringers, let it be, and trims of frames. And now the wing assembly jig of little airplane. It's for little military airplane. Simple, easy peasy, you see? And maybe it's not everything we understand yet. That is for stabilizer of rather little airplane. And it's already for the fuselage. No, that one looks, as for me, It looks rather simple by the word. Someone lost it. Here happens. And the most complex, of course, the aggregate assembly jigs. For assembling the wings, for assembling the whole fuselage, they are the most complex. Not because of no, not because of sizes of aggregates, but because of complexity of aggregates themselves. And if we already passed stages of preliminary assembling, like unit assembling, for instance, or even section assembling, in this case, it simplifies the arrangement, the structure of assembly jig for aggregate assembling. And it will be more convenient and more simple to work at the stage of aggregate assembling. Very well, but do pay attention to such effect. No, what, for instance, to this one. Look, this thing that is a tool, seems like, for our assembling. No, it's not a tool, actually, it's a tooling, because no, to be frank, it's maybe considered as tool. Those things which are so-called locators, the basis of assembly jig, you placing the elements of structure to these locators. And these locators, they are responsible to find proper place with respect to each other. In terms of transformation of spatial position, they will be the tool. Well, typically, it's called tooling. All these assembly jigs, not so important right now, maybe. I promise not to ask such a question, whether it's tool or tooling. But do remember what did I say? What I'm going to say now. This tool must be more accurate than the aircraft we produce in this tool. It's obvious, yes? Tool always should be more accurate, practically always, when it comes about mechanical tools. Is it more accurate? Should be than aircraft. And I'm already said that it's dreadful task actually to assemble aircraft from pieces of big sizes, of low stiffness, with very high accuracy. And what do we see here? We see a lot of pieces of even greater sizes. Looks, they are also not much stiff. Of course, they are not so delicate as aircraft structure, but not so stiff, and should be even of higher accuracy. How to provide this preliminary task? How to assemble the assembly jig itself first at the stage of pre-production? How to provide accuracy of assembly jig? Next, people look, how to provide coincidence, commonality. It's called coordination. In English, correctly, it's called coordination, the matching of sizes. For instance, these locators and their positioning in space, they will create some complex shape of the aircraft. Let's try to notice something. No, where it's regular, like cylindrical, it's nothing to talk about. But where it's something like nose fuselage or aft fuselage, or some places like this, for instance, how to positionate them, how to produce separate locators, especially having computers, having CNC machines. Yes, but how to locate them in space properly? There is a question. Next, how to provide coordination not only between them during assembling of assembly jig, but also you do remember we have thunder and lightning. Sorry. We have beforehand we need to produce panels, for instance, in panel jig, and it means that panels jig should be coordinated with panels for fuselage. Jig, they should be coordinated with the jig fuselage compartment or aggregate at all jig. And moreover, they should be coordinated with the punches for manufacture. They should all give the same results. How to provide it? These techniques of providing of coordination, one of them you certainly already know. As you are not first years, you already know such things like fits and tolerances. accuracy and assemblability providing by using interchangeability even and assemblability providing by using approach of fits and tolerances. When you normalize the sizes deviations, they are called tolerances. You appoint tolerances and follow to these tolerances. When you normalize tolerances, normalize sizes, and due to this following to ranges of deviations of sizes, you provide final assemblability of objects, working great, if not the one important peculiarity of aircraft, non-stiffness of parts. However good you produce the parts, they will find way to spoil itself, just on the way to the next shop. They may bend under their own weight, if even you place them in the supportive device. This technique doesn't work practically. It's work only for massive parts. For instance, for landing gear, it may work. For elements of fuel system, some pipe, pumps, hydro cylinders, work very well. For manufacturing of brackets, some massive parts works very well, but not for airframe parts, which looks like eggshells, typically, you do remember, or like strings. And in this case, we use another techniques of coordination, which based originally they were based on the using of natural copies of the airplane, so-called mock-ups, but not even mock-ups because people were not able to produce these mock-ups originally, and they don't need these mock-ups actually. They've been using cross-sections of mock-ups in different direction, and it's called templates. And to provide the coordination of all the tooling to be for airplane to be produced, to all the contours, outlines, and so on. Actually, we are in aviation, in aircraft manufacturing, have stolen something. Do not tell to anyone. But what we did, no, actually, any aircraft engineer knows this. Such a beautiful picture is called loft. In English, loft means the same meaning that attic, the top floor of any building, which covered only with the roof. Something like technical floor, which has only a floor, immediately a floor, and roof. That's it. And when when aviation age have started and we need to produce dozens of airplanes already, what we did, we have copied and developed, of course, next ambit technique that been used in ship manufacturing, ship vehicles, sea transporting vehicles. Well, I'm afraid that we need to finish our class. Right now, it was last lecture to you. Also, you will have some records of video records of practical classes. Among them, you will have additionally one task about technological process. It will be about sheet stamping. And among those classes, I'm also going to explain you, but in more practical way, not so conceptual way, about some techniques of coordination. Not much, because really it's the most difficult subject. Not even assembling is the most difficult. It's one of the most important fields in aircraft manufacturing, assembling, because it's exactly assembling determine final quality of the aircraft, to be frank. But coordination, like system of complex of processes that start far before, not only assembling, but far before production of first ever part of any aircraft. This coordination is like central point of any aircraft manufacturing, and it start, I'm already said you, practically since the moment when designer start their design project. Very well, right now I will stop, and additionally some practical classes. What I forget to mention in our lectures, I will try to compensate you in practical classes. See you next time, for me maybe in some minutes.